My name is Eugene Vestal. I will be talking about a exploration of how we can convert clinical quality language to SQL. A little bit about me. I'm a founder of FHIR-IQ. I'm from Pittsburgh, Pennsylvania, and you can find me as a FHIR data guy, author of FHIR-IQ Playbook on Substack, also run the Out of the FHIR podcast. And I have 15 plus years of healthcare experience in all kinds of different areas. I graduated from University of Pittsburgh Healthcare MBA program, and I've worked pretty much in every area of healthcare you can imagine. I'm excited to be presenting. So why is quality measurement so hard? You can see the complexity here from this image generated by AI. As you can see, the standards complexity, manual point solutions, lack of integration. Clinical quality language was meant to give us a standard computable way to express clinical logic, right? A shared language for quality measures. The intent was right. The reality is a little different. Writing CQL takes too long. Maintaining it takes even longer. Executing it requires specialized engines. And most organizations don't have a CQL engine, right? So logic is defined in CQL, but the execution continues to happen in CQL, SQL, and it's an expensive administrative burden. Quality measurement has long faced a huge administrative cost on the US healthcare system. And so we have to come up with solutions that are open and scalable as well as don't add to that cost. So the agentic shift. With the advent of AI and AI agents, it is really a huge monumental shift in ability to scale solutions and technology across healthcare. So in this pyramid, you can kind of see with FHIR and JSON being a structure and transport layer, it's still hard to analyze and run analytics on it. CQL is the clinical logic language. It is defining the rule book, the clinical logic for healthcare. And SQL still remains an analytics powerhouse. It's great for analytics. Every organization has SQL that they run. They have people that are familiar with SQL. And then we have AI agents. So the AI agents can really become force multipliers across the board to take the administrative cost out of the system and really improve the efficiency of how we measure quality, run analytics on healthcare data, and deploy these solutions at scale. So what would this healthcare analytics house model look like? Well, we can start with a foundation of a standards-based computable layer with clinical logic serving as the blueprints, CQL definitions as the specifications, value sets terminology as the what, and FHIR specifications that give us grounded standards-based frameworks for healthcare data. What is the main floor? The main floor is the analytical stack, scalable, vendor agnostic. We can create FHIR to SQL views using CQL on FHIR, SQL on FHIR. We can translate CQL to SQL using translators. And then we can store terminology and execute all of that using readily available modern SQL tools. We can then generate measure results and share those freely amongst the healthcare participants. And then the roof is the action layer. So we can write back the measure results to FHIR and then make it available for payers, providers, and patients. We can generate tasks or actions, which is what the patients are asking for. What am I going to do next? And have AI agents execute automation and give us real-time benefit to doing all of this work that currently just sits behind administrative offices. So let's go into the demo, and I will demo how an agent can write CQL, use the CQL converter to convert it to SQL, have an agent create SQL views and load it to Databricks, execute it, and then share it with other solutions. I'm starting in Claude connected to a CQL Builder MCP server. And this setup does something we've all wished existed. It lets a generative model write CQL within guardrails. So here I'll prompt it something like use MCP server CQL Builder. And Claude uses structured MCP interactions. The available functions here are generate CQL, validate CQL, and push to FHIR. So I would like to create a CQL measure based on the latest AMA guidelines for breast cancer screenings. So it does the research on the latest, what is the latest AMA guideline from US Preventative Task Force. And once it has the guidelines, it is able to use the CQL MCP server to create the structured CQL prompt. So we have what is the purpose, measure type and scoring type, what is the target population, and a problem statement. As you can see, it also retrieves the following value sets that are applicable to this particular measure based on the guidelines. And the value sets are identified using Value Set Authority Center on the National Library of Medicine that is automatically pulled in by the MCP server. So now we see it's kind of generated the CQL measure based on the USPT STF 2024 breast cancer screening guidelines. And we can see the CQL that's being generated here. Based on those guidelines. And it's summarized by the MCP service. So we can see this is the CQL measure that it's created. And there's the final CQL code. So now I'm going to ask it to push to my Plum FHIR server. And here's my ID and secret. And it's retrieving the CQL library. So there it is. Now it's been deployed. And we can view this in MedPlum. So we can either execute, evaluate, measure, we can create test patients, or we can add this measure to quality reporting. We're actually going to go ahead and we're going to use the CQL-to-SQL converter now to convert it to SQL. And now we're going to transform the CQL that we generated to SQL using the CQL-to-SQL converter MCP tool. And as you can see, it will download the CQL library. It's going to validate it and then create a CQL to SQL So it goes through a series of checks so that it can convert properly the defined statements from the CQL into CTEs and SQL, and then also generate the applicable views on the FHIR resources that are needed. So as you can see, this is the generated CQL SQL query. This is the resource views. So now I can execute this on Databricks, or I can convert to another dialect. Let me show you what it looks like when a full CQL measure goes from authoring, validation, SQL generation, and then execution in Databricks all in a single pipeline. The goal is simple: to make CQL not just the documentation, but executable analytics that runs everywhere SQL can run. So here's our CQL measure, standard logic pattern, and I'm going to load the CQL by connecting to the FHIR server. We're going to go ahead and select the CQL library and measure. We're going to connect to the terminology services to pull in the value sets. Then we're going to go ahead and ingest this data to Databricks. We're going to connect to create view definitions based on all of the FHIR resources and the measure itself. And we're going to go ahead and convert CQL to SQL. Then we're going to review and approve the SQL. We're going to approve the contract and the quality of the data. We're going to go ahead and execute and generate the measure report in Databricks. And we're going to go ahead and write back the measure reports to the FHIR server. And we're going to review the statistics. So this kind of presents all of the steps needed to execute is a standards aligned analytics stack for FHIR. CQL defines the logic, SQL executes the logic, and the warehouse brings the scale. I'm not going to go back and dive into the converter, CQL to SQL itself. So the step where we converted it to SQL, we can see the process by clicking on the Start Demo. And we have CQL presented here and SQL output here. So we can see the generated SQL query and the same measure report that's generated. So the output of both the CQL and the SQL remains the same, which is the standardized measure report. And we can tell what the process is for generating the SQL by looking at the transformation pipeline, which parses the CQL source code, analyzes the structure, and then generates base FHIR views and converts defines to CTEs. The schemas that we have are generated based on FHIR, and you can see it automatically assigns the right constraints while at the same time flattening the FHIR structure. In addition, we can see that there are different functions that convert from CQL to SQL. So there's a whole document structure here that everyone can go and explore. In addition to this being a project in draft mode. So what are the 3 steps you can do to start exploring this as well? You can, look at CQL authoring tools and invest time in learning CQL to define the logic and use the CQL builder. You can wrap your existing data platforms in MCP servers and bridge the FHIR and SQL worlds. You can hone in on specific use cases to tell a story. and you can start creating agents for tasks like automating, CMS or CQL reporting, improving data quality, and achieving true conversational interoperability. You can go and check out these resources here. Check out the FHIR-IQ playbook, open source CQL-to-SQL repo, and you can also play with the demo and the POC. And you can also reach out to the SQL on Fire working group on Zulip chat. We're hoping to kickstart this kind of work as part of that as well and collaborate with as many people as are interested. You can find me on LinkedIn, follow my Substack and podcast. You can also join the Open Quality Early Adopter Program with FHIR-IQ, Databricks, and FHIR Metrics. We're trying to start a community for folks that are interested in open quality measurement. And hopefully Arjun Reason Health will also participate, as well as Health Samurai and other folks. Questions?
So thank you very much for that, Gene. I just want to say, really incredible work. I think there's some comments from the audience as well. If you are steeped in the digital quality CQL world, what you just showed was an amazing packaging and collection of these super advanced LLM tools and the end-to-end workflow. So yeah, really great work. I wanted to say that first off. And definitely just to the audience as well, this is an indication of where we want to go as a FHIR analytics collaborative, right? A lot of today's sessions are about AI in different aspects, but as you probably well know, digital quality measurement, data quality, 0057 are really critical changes happening to the healthcare system. And so us as a collaborative, we want to be helping lead that in a particularly open standards way. So this really shows the power of these tools in that context. So I think we've got a couple of questions for you, Gene. One is from our friend Benji. Have you benchmarked the performance of this versus FHIR-based DQM measurement in an all FHIR server without using SQL on Fire?
We have not. So this is kind of like taking the idea of, we know that SQL-based, quality measurement works. It's been done for many years. It's live right now and being used for HEDIS submissions, right, at, very large organizations. And CQL is something that we're building. So my call to action here is to try to take CQL as a, input into that infrastructure that already exists and try to scale it that way. And we know for sure that there are, systems that can process all of this data. And I would imagine the performance would be similar, if not better.
Yeah, I know, I'm aware, and of course our friend Benji is well aware that the performance of CQL execution has been a major topic, and there's a lot of work being done right now. And I think that comparative aspect from how quality measures in particular are executed today at scale versus CQL at scale versus something like this, how does that affect what the scalability performance will be? And from my perspective, not to editorialize too much, but I'm kind of a let a thousand flowers bloom kind of guy. Like, let's try lots of different implementations, lots of different approaches, because these are such hard problems with such complexity and people have different needs. So on that, we have another question from David Rose. Can you speak a bit more about how the MCP server provides context to the CQL to SQL conversion to ensure the SQL is written correctly to run on flattened data?
Yeah, so again, this is a work in progress, and that's why I call it exploration, because there's a lot of work to be done to kind of create an end-to-end solution. But we know this works, right? We know that there's SQL-based quality measures that run currently on many different data warehouses, and the only difference is that we don't have a standardized schema. So FHIR provides that standard contract for us. And CQL serves as a really good definition of how to build clinical logic in FHIR and use terminology for that. So the way that you can explore the POC and the demo that I shared earlier, the way that I'm looking at it is we use it as a package. So CQL defines the what, and then you use that to flatten, here's the FHIR data that I need to execute this measure. Here's the terminology that I need. Go retrieve that terminology, flatten that, and store that in your data lakehouse or analytics warehouse that you're using. And that's what ends up being executed. So there's a direct correlation from CQL is the blueprint, and then LLM is the agent that does the conversion using pre-built prompts and training it on many different examples so that it's less, it becomes more deterministic.
All right. Well,